Okay, so let's continue. Quadratics in 3.1. Find a quadratic function whose graph matches the one below. I would suggest you do it in the a times x minus h squared plus k form because the vertex is really easy. Now if we look at this, our vertex here is 6, 4, which means that my h and k are 6 and 4. So the only thing we actually don't know is a. All I have to do to find a is plug in one of the points that's not the vertex into the function. So I'm going to take this point 7, 2. So 2 equals a times 7 minus 6 squared plus 4. 2 equals a times, this is 1 squared, which is 1. Subtract 4. A times 1 is just a, so negative 2 equals a. So put that back in the function. F of x really equals negative 2 times x minus 6 squared plus 4. So this is not too bad. If you can see the vertex, it's not that hard to find the function. You just need to plug in one non-vertex point to find the a and complete it. There's some word problems here and some extensions to things we've done in the past. Find two numbers whose sum is 28 and whose product is maximized. So we want x times y to equal 28. And we know, not times y, x plus y is 28. We want to maximize x times y. Now how are we going to do this? Substitution, y is 28 minus x. I can put that in. X times 28 minus x is 28x minus x squared, or negative x squared plus 28x. When does the max occur? The maximum x value is at negative b over 2a. Here, that would be negative 28 over 2 times negative 1. That's negative 28 divided by negative 2, which is 14. If x is 14, y is 28 minus 14. 14. So the two numbers whose sum is 28, whose product is maximized, is 14 and 14. The reason for that is that's a square. The square is the maximum product you can have for a given perimeter. So, well, I should say a four-sided figure. Circles can technically do more, but the square is the maximum for a two-sided figure, which is how this works. Now, I know you're probably tired of the projectile problems after chapter 1, but we can do more here. A projectile is fired straight up from ground level. After t seconds, the projectile's height is s equals negative 16t squared plus 176t. Find the number of seconds it takes to reach maximum height. So again, this is another x equals negative b over 2a problem. So that's negative 176 over 2 times negative 16. Negative over negative is positive. This reduces to 11 over 1. So it's 11 halves, or 5.5 seconds. Find the maximum height. This is the y value. Again, you don't need to use that formula from the last video. You just need to plug this in. Negative 16 times 11 halves squared plus 176 times 11 halves. This is 121 over 4. To square a fraction, you square the numerator and square the denominator. 16 over 4 is 4, so this is negative 4 times 121. 176 over 2 is 88. From here it's just multiplication. Negative 484 plus 968, which is positive 484 feet. So it takes 5.5 seconds to get to max height, and that gets to a height of 484 feet, which is all things considered pretty impressive for a projectile. Okay, now, good news and bad news. We still have completing the square. Convert f of x equals x squared plus 2x plus 7 into vertex form by completing the square. Give the vertex, axis of symmetry, domain, range, max or min, intervals in which the function is increasing or decreasing, and then graph. Okay. So, to get it into vertex form, we can complete the square. I'll teach you an alternate method on the next problem we have to do it. To complete the square, again, we have to complete the square on x. So I'm going to subtract the 7 over. Then I'm going to leave my blank. complete the square, I have to divide by a, but it's 1. Take 2, divide it by 2, which is 1, and square it, still 1. Anything I add to the right, I have to add to the left. Combine your terms. This is f of x minus 6. This is now x plus 1 squared. Move the 6 back over. So f of x equals x plus 1 squared plus 6. So that's our vertex form. That means the vertex is really easy to find. It's negative 1, 6. Axis of symmetry. Remember, it's a vertical line, and it's always x equals whatever the x value of the vertex is, which is negative 1. The domain, you should never miss this. The domain of every quadratic is negative infinity to infinity. The range is, this opens upward because it's positive. So it starts at 6 and goes upward. So our minimum value is 6, and it goes to infinity. It'll either stop at your value if it opens downward, or it will end at your y value of your vertex. Either starts or stops there, and it goes to either infinity or negative infinity, depending on if it's opening up or down. Besides the range, it says the max or min. It opens upward, so it has a minimum. This is a minimum of the y value of 6 at x equals negative 1. So this is just another way of writing where our vertex is. Increasing, decreasing. So if it's opening upward, thinking about the shape, it's increasing, or it's decreasing until it hits the vertex. It's increasing after the vertex. And these are the x values of the vertex. So from negative 1 to infinity, on the right side it's increasing, it's decreasing from negative infinity to negative 1. And the vertex is never included because it's technically flat there. Lastly, graph the function. We know we've got the point negative 1, 6. From here, it's a matter of plugging in points. If you plug in points near it, I know if I plug in 0 from here, I get 7 because I have the original function. So up 1 over 1, so 0, 7. That means I have negative 2, 7 by symmetry. And lastly, we can plug in one more point. Let's plug in 1. 1 plus 1 squared. So 2 squared is 4, plus 6 is 10. So we have 110, which means we have negative 310 as well. From here, it goes off the graph. Okay, so what do you do if you forget how to complete the square and you want to get it to vertex form? This is where your x equals negative b over 2a really comes in handy. You can find the vertex and use that to make your vertex form. So that'll take by completing the square, but we're going to do it by finding vertex and being clever. Negative b over 2a here is negative 8 over 2 times negative 2. So negative 8 over negative 4, which is 2. I plug in 2. We have negative 2 times 2 squared plus 8 times 2 minus 5. It's negative 2 times 4 plus 16 minus 5. So it's negative 8 plus 16 minus 5, which is 3. Means our vertex is 2, 3. Now let's recall here, how does our vertex relate to vertex form? Remember, they go in there, the x value goes in opposite sign with the x, and the y value goes on the outside. The only thing we need to know is a. So a times x minus 2 squared plus 3. Now what do you notice here? To find x, the value of the vertex, I needed negative b over 2a, because a is the number in front of x squared. That is actually the same a down here in vertex form. So once you find a, that a just drops down into this equation. So you just bring it down. So this is actually negative 2 times x minus 2 squared plus 3. And we'll do the last problem in the next video.